My name is Tatiana, and here is Arvid. We are from Norway. But I was born in Russia, and my mother was part of a Russian space program. So my twin sister and I grew up on a lot of stories about space exploration. And while preparing this talk, I remembered one of them. What do you think is the most difficult part of training for American astronauts? It is an idea.
The time shift, the darkness stuff.
It is an exam in Russian language. Russian language training is a mandatory requirement for all participants, for all candidates for American space program. Why? Well, Russian was the first language that was spoken outside this planet, if you don't count aliens. That's a huge source of pride for me, but it's hardly a reason to make people learn a whole new language. So this requirement has nothing to do with history, and it has nothing to do with politics. It's not Russia that enforces this requirement, it's NASA. So why? In 2003, Shuttle Columbia crashed, and that ended American-owned shuttle program. And since that time, the only way for people to get to orbit and return back is Russian spacecraft Soyuz. Now, of course, all controls in Soyuz are originally in Russian, but it's not such a big deal to change the controls. It's much easier than to make people learn a language. But according to the agreement, it is always a Russian who is the captain of Soyuz. And Soyuz is used to take people to the orbit and return back. And these are the most difficult and the most dangerous parts of all space expeditions. And emergencies happen. And NASA realized that in case of emergency, the most efficient way for the crew to communicate will be if the captain and the command center speak their own language and the rest of the crew understands and is able to follow the orders. In this, yes, captain and the command center know English. But in these situations, not only seconds, but split seconds matter. And there is no time to phrase something, to think how to phrase something in a foreign language. There is no time for translator, of course. So the most efficient way is to speak your own language. And for this only purpose, to establish this most efficient way, month and month of training. As you see, considerable effort. And quite a lot of money is spent to make American astronauts learn Russian in order to establish the most efficient way for people with different origins to work together. And this is the topic of our lecture. Style-guide-driven development is a new way. It's the most efficient way for people from different origins, designers and developers, to work together. We are going to talk about what it is, how everything works, but most importantly, how to get there, how to start working this way. We shall cover this from both perspectives. I'm a designer, I'm responsible for the design side, while Arvid is taking care of the developer's perspective.
Yes, hello. Software developers have talked a long time about reusability of code and write once principle. As a result, in 1967, the object-oriented programming was born. The first object-oriented programming language was implemented by two Norwegians in 1967. It was called Simula 67. The pattern is then 50 years old and still going strong. Object-oriented programming allows the developer to join a set of properties and group the properties with operations. On high level, it allows the program to give the properties and operations to an object, meaningful names, as well as hide internal data structures and business logic. You probably all know all this. But the developers that's going to use your object don't need to understand all its internals. Then we have model view controller, which is also an old pattern. describes how the data is modeled, how it's viewed, and also how you access its data. And the view can even update back the data if it's modified in its view. By learning and applying patterns, developers get into well-known ways of how to structure the code. Patterns allow us to recognize the way the code is crafted. Style-guide-driven development is also about patterns. Our pattern is how we define the structure and the layout of elements equally or as equal as possible on the design and the development side. We are taking the designer into this development pattern. So how do we work now, or what we see happens very often in the project we are involved in? We receive a nice looking screen, or a set of screens, and they are called the final design. And then you build element by element out of that. Take this element, this button. You use Bootstrap or some other framework, tweak some parameters, and then you make the appearance fit the design. Then another button, and okay. Okay, let's hope it lasts. And another button, and this has 1 pixel taller than the previous button. And then you need to tweak the parameters in order to match the design. This was an actual design received from a designer that did not work with style guides. So here you see they are slightly different, but also the same. And you see also the difference in this one has capital letters, this one has not. And then if you see 2 similar elements, this takes label here and this one here. If you work this way, you will most likely copy the parameters, and then you don't have any measures to reuse them. So then you just implement another label and as a copy of the previous element. So here we have a lot of instances and a lot of different non-system. None of these parameters are standardized. So it becomes a mess. Also, you need to reverse engineer the rules, how these elements are laid out in the interface. And there is always room for interpretation, no matter how detailed the specification is. So this header is 24 pixels from the input below. Is it the header that has 24 pixels padding, or is it the input, or do they have 12 each? And now it's not an input, but a text right below the header, and the distance is 32 pixels. How did that happen? You need to analyze a lot of screens to reverse engineer each individual rule like this one. And then you receive another set of screens, and there are some buttons that are slightly different, and someplace the paddings do not match the rules you have derived out of the previous set. So you need to apply adjustments in these cases. This is a struggle people seldom hear about because the developers just suffer in silence. So working like this, we cannot reuse much of the elements we use. And the design system is messy, and it's very difficult to maintain. Style-guide-driven development is building the interface not element by element, but as a system of reusable components. If the elements are standardized from the beginning, if they are put in the library and reused both by the designer and the developer, we don't need to make them all over and have tons of variations. if the design of screens come along with the design system, if the rules how interfaces built are made explicit, there is no need for reverse engineering. So SDD is the pattern where we establish a design system and a library that supports it.
So the essence is working with this established library and the rules. And the key thing here is that both the rules and the library have to be created by both designer and developer and used by both. And now when I'm saying designer and developer, I don't mean two people with these job titles. It can be design team and development team. It can be design department, development department. Or it can be just one front end that does everything. Then it will be about parts of his work. So it's not about job titles or quantity of people. It's about the work, the parts of the work, the aspects of the work that needs to be done. So what's the work? We have to establish the library. And when establishing the library, you have to understand what components, what elements you put in this library. So we need to break the whole interface into these elements. Here we have some interface. And some of the elements on this interface are easy to see. A button, an icon, a checkbox. These are the smallest components of the interface. We call them the basic components, the smallest standalone elements of the interface. So say a dialog is not a basic element because it can be broken further on the buttons and the text and the background, while a label on a button is also not an element because it does not exist without a button. It's not standalone. So the basic elements, the foundation of the library, are the smallest standalone components of the interface, like this. What we do, we call them once, and then put them in the library and reuse all over the interface. Great. But that's just the beginning. Because the interface is not flat. It's not made only of one level of components. We see that combined together, up there, smaller elements create something bigger. Here's one, here are 4 others, here's another one. These are bigger building blocks, more complex components, and they can also be reused. They're reused here 4 times. When we go further, we see that this header includes this first bigger component inside. So the level of complexity of these bigger elements differ. It grows. And as we go through the interface, we'll see that it grows on and on. And our task is to establish, to understand this hierarchy of elements when we are looking at our interface. And this hierarchy sometimes is described on examples from chemistry and biology. So the smallest elements are called atoms, these red ones, while combined together atoms create molecules, and then there are organisms, etc., etc. I will not go deep into this topic of hierarchy. First, it's a design topic, and it's much wider than the scope of this lecture. And I will leave all these molecules and all these atoms to natural sciences and to design. What is important here is that the basic elements, the smallest elements, and the complex elements, we'll differ them only by this one measure. And the important thing here is that the basic elements are already globally defined. We already know what a button is, what a divider is, what a checkbox is. We just have to recognize them on the interface, decide how it's going to look, build it, and put it in the library. While for complex elements, we have to define them ourselves. And moreover, we have to define them for every project, because they differ from project to project. The basic elements reappear almost in every project that you face. The complex elements do not. So that's what needs to be done when we are starting working on this library and this design system. It's the work that is done by designers and developers. All right, we have elements. We know what we put in the library. What do we do with them? We need to understand what properties, what parameters they are defined by, what units we are using, and how we measure them, and how these measurements change depending on the content. And this how we measure matters a lot. Here's a button. It has color, it has font color, it has size. Now, as a designer, I can define the size of this button at the total width and total height. I think that these elements are going to have this width and this height. But you in your head, not knowing what happens in my head, may think that the size of a button is defined by the total width and the height of the label plus paddings. And just by looking at a button, say in Zeppelin, in Vision, just in the mock-up PNGs, you do not know what's happening in my head. You do not know which rules I use when drawing this button, and you apply yours. Okay, you have coded this button and put it in the library, applying these rules. Next time you see this, and it doesn't fit. Because by your rules, it has to look like this. So what you have to do, you have to apply adjustments to make it look like my design. And this is exactly what we are trying to avoid. We are trying to avoid the situation when, in order to put an element in their interface, you have to apply custom adjustments every time. We are trying to achieve the situation where you can take the elements directly from the library. And for that, we need to agree on how we measure things. And I'm not discussing now which way of defining a button is best. It doesn't matter. It doesn't matter that we do it the best way. It matters if we do it the same way. That's what matters. And the same is about responsive behavior. If you get a series of screens, or one screen or series of screens, you do not necessarily see what are the rules, how things change depending on the viewport or the content. You have to discuss the rules and explicitly discuss them, and then understand on both sides. Yes, okay, one thing done, properties. Then we have to understand how we shall call these things. And calling elements with the same names, of course, simplify the communication. We understand each other. There is no misinterpretation. But it's not only about communication. It's also about helping each other to understand the structure and the hierarchy of the elements of this type. Button, primary, basic, small. Button, what type of element? Primary, use. Primary, secondary. We have to agree on what types of use we have. Basic, who, small. We have to understand what are the states of this element. Small, the size. We have to discuss, we have to go through all these parameters, all these things in order to establish the naming convention, in order to, after that, to name things properly. And this agreeing on the names forces us to do this. And one more thing that we have to discuss is how the elements should look and behave. And the most straightforward answer is the elements should look and behave the way the designer has decided. And you can implement everything, right? But the question is if you should. I'm not saying that you should influence design decisions. I'm saying that you have to help us make informed design decisions. Because no matter if you like custom components or not, for some people it's the higher the hedge, the more fun it's to jump over it. For some of them it's trouble and all this. But no matter what is your attitude, whether you like it or not, it's additional development time. And additional development time is additional development cost. We have to consider this. And also, it's sometimes, often, increased probability of issues. It's sometimes reduced performance. You know that. But by default, I don't. So when I make a decision whether to put an element in the design or not, how do I do this? Because it looks cool and because it's user-friendly. But also we have to include in this formula the understanding of complexity of this element. Because what makes this slider difficult for iOS and Android? Is it this non-circular knob? Is it an icon on this knob? Is it a wider background? How difficult it is making this? I have to understand this because this slider also looks cool and is user-friendly, and I can easily go for it too as a designer, but that's a slightly different story from your perspective. So we have to agree on this. Yes, very often we go for complex custom elements, but in this case, we make this decision with our eyes open. We know what it implies. So this discussion, again, matters. So these are the things we have to go through when we establish the library, what the elements are, what are their properties, naming conventions, and look and behavior. And the important thing to understand is that we don't do this in one go. We don't create the library and then work with it. We are creating the library as we go. We are creating only the elements we need for this current release, current series of screens, and it's a continuous process. And establishing the library is part of the work. We have to work with it, right? But that's your library. This library is built. It's a front-end library. Now, I draw. I'm a designer. How do I work with your library? When I started looking for answer to this question, the only one available was this. Designers should work in browser. And this is a dead end. Now you may think, okay, here's another one that is afraid of coding. No, myself, I have some IT background, and I'm not afraid of coding. It's not the concept of coding that scares me away. It's the concept of designing by coding. Designing by coding is designing by describing what you want to achieve, describing. And that is the total opposite to designing by doing, designing by direct manipulation. Designing by doing is the way all creative visual work has been done since the beginning of times. A prehistoric man took a stone and applied it to a wall, and he sees the wall change the color. Oops, I can draw on this thing. And here's a bull. He saw this wall change the color. Okay, I'm not jumping. I guess we have to change the cables. No, yes, no. Let's see. You can admire the bull so far.
The cable seems a bit broken, yes.
Yes, we were warned that cable is not great. Nice pause about the bull. Okay, no bull now.
Yes. Nothing happened? We have alternatives.
I guess this must. It's not about the laptop, it's about the cable that's here. It's not about us. Well, it's the cable that is broken, and it's not our cable. So, thank you, but it will not work. Well, last time when we were giving this talk, the slides were stretched, and all the black slides were getting lower in the color. So we've been doing this before, so that's not the major problem we have faced so far.
Looks like it was the power supply of this distribution down here that was a bit fishy, but now, after changing the cable,
Well,
let me try to switch back to the old one.
Have you solved the problem? Can you just try to jump back to the old one? I'll try not to jump on the stage. Okay. There is a bull. Don't touch anything, please. Okay. Back to what I was discussing. So when this prehistoric man was drawing this bull, he saw the wall change the color exactly as he was applying the stone. Okay. Let's continue.
Is it no chance?
A child takes a pencil and starts drawing, and he sees the paper change the color exactly where he's applying the pencil. he draws more and the color becomes more intensive. It's direct manipulation. He's creating with this drawing and the things happen exactly where he's applying this manipulation. A sculptor is changing, manipulating with some model in clay. Drawing in design software, we are doing the same thing. We are changing, rearranging the objects. It's a direct manipulation. While when drawing by code, designing in browser, it's like you blindfold the artist and suggest him to describe how he wants the strokes to lay on the canvas. Then open their eyes, see the result, and then describe the changes he wants to make. It's a funny experiment. You can draw a smiley face like this, but it's kind of difficult to draw a Mona Lisa this way. You have to see what you're doing, and you have to do it where you are doing it. Well, I'm not saying that we draw Mona Lisas every time, but when we need something a bit more complex and well understood, well standardized view, we need an ability to draw, to design by doing. This is why designing in browser will not work. Well, I'm talking about it now, so apparently we have found a way to work. The way to work that we have found is we create an exact replica of front-end library in our design software. Sketch and Adobe allows this. And we have the same library elements. They look the same. They are structured the same way. All the inheritance, all the parameters are the same, both in your elements, in your library, and in mine. This is how a button is described.
I tried to plug to my phone.
No. No. Present on the device.
Well, this one breaks also. It's the.
Yes.
It's not my PC.
It is not a PC. Can you please go back? Yes.
You can try to reduce the resolution. It sometimes helps to.
No, it's not about the resolution. It's about the cable. Well, I guess we shall try to continue as we are, and we shall just hope that this will gonna work. Yes. So we create the exact replica of front-end library in our design software and synchronize where it matters. And the main change that happens is the change in my workflow. I'm allowed to draw only with elements from this library. If I need something new, I create this something new in the library and then use this in the mockup and then send to you both this element and the library. So as a result, you have the mockups that can be implemented directly from what I sent to you. And how they're going to be implemented, Arvid will tell.
Yes. In style-guide-driven development, components are a very useful construction pattern. The components allows us to write maintainable code. We combine styling, view definition, properties, and logics for basic or complex element in a separate part of the code. The easiest way to go is to select a framework that supports components natively. So if you do not select such framework that supports it, you'll be forced sort of to organize the code in a similar way. The basic principle about components I will show you in a very trivial example from Angular, if I'm lucky. So the component is a construct to keep together relevant information how to render, its data and operation, including how it's styled. This is a component, very basic. In this section, we have the template section defining its view, how it's rendered. It can also contain interactions. There is no interactions in this basic example. It's a bit annoying, this. Here we also have some basic styling elements. It's nothing revolutionary, just plain HTML tags. Here is the useful stuff for the end user. And here are the parameters that are fetched from the data object. So yes, a very basic example. Here you see maybe a more piece of code that is more real life. So here is from a real application where we define these components in this code, where we also have a more advanced styling and layout, grid system, and also some what happens if you click and type in the dialog. And here is part of the implementation code behind this component. And it has some data, and it has some functions to manipulate its data. So to summarize, here is how the component pattern is useful. Styling, view definition, properties, and logics for basic and complex elements in separate parts of the code. The styling system is important here. The styling can change the visual appearance and the layout of the components without changing the components themselves. So how do we transfer styles into real code? Here's a design system that we receive from the designer. We start by laying out folder structure in our code, and we typically use this layout. Bundles is the term we use for complex elements, a combination of basic and or other bundles. Here is the same example. Custom value stepper for gift cards. It's a complex element, it's a bundle, and consists of this input box and two buttons, one on each side. And of course, we can reuse it also for the quantity stepper. It's the same component. Elements are the smallest useful interface component, like buttons and labels. And the Buy Now button is one of these basic elements. The text of the button is not part of the element definition, since every button can have different text. But all the rest is, they are sharing the same definition. The root folder is where we put all our global definitions. I will come back to that one in a second. This file loads the other structure, so it's just to describe that. Back to the root folder. Here we put all the definitions, and we define parameters once and let all the elements inherit or refer to these parameters. The hierarchy of the parameters should reflect the design system. So here we put color definitions, paddings, margins, other layout parameters, font definitions, grid systems, which all elements implicitly inherit and utilize. So how we, now I'm going to show you the link between the design system and code more directly. Here we see the color definition from the design system. Then we code this one-to-one and define each color only once. So let's follow the primary color throughout the application or the code. So here in our root folder, we define something called link color, and that is our variable. This allows us to gather all these into an organized chunk of, or a place where you put all these variables, so it's easy to change the whole style. And then eventually we put this link color into the A definition, since it's a link. So this is how, so default A's become having this color, and if you need to change that, you need to make an override of this definition. And then we can, if we are not happy about this color, then of course it's the designer who decides that we should change it. Then you change here one place and all the interface will have updated its primary color. Let's have a look at the typography definition. That is defined in the root folder too, but we have a separate folder for that. And here is how we define the font. So we use something called a golden ratio to define the fonts. So we basically calculate the different types. But pay attention to that we have the namings here coming from the design. And you see the H1 tag is called the main title. Then we calculate the font sizes based upon this golden ratio, also the line height. And these calculations are reflected in these values. So we don't hard code these values, we calculate how the fonts should be, how the different sizes are laid out. And here we have 4 parameters that we tweak in order to change font sizing. Let's follow the H1 tag and the main title throughout the code. We have font size definition and line height definition here. And then we have an intermediate layer that allows this, where we define all the parameters. And then eventually we put font size and line height in here based upon these ones. And here you see also its use in actual code. And here it is in the interface. So this is how we implement styling in our library. And we can take our library even further. We can make separate screens or views that shows the elements and bundles in a preview. A live style guide is a separate set of web pages or separate app where all the elements are used, which is used in the product, are listed and shown. It can be buttons. Basically, all elements can be laid out here so that people can preview them, and that is the live style guide. This example is from MailChimp. So let's summarize the advantages of Styleguide-Driven development. The rules are automatically applied to new elements when they are created. If you need to use overrides, it's an intentional action. So it's very hard to make mistakes like accidentally making a button with wrong size, have slightly different color because of typo in the hex code, and so on. Easy to make changes. When doing redesign, we use the rules so we can change the interface in a smooth way. Also for white labeling, having design rules make it very much easier, especially if you have this folder structure so we can replace a chunk of parameters. And the way we organize the resources and rules is very structured with SDD. And it improves the quality. So less need to verify design mistakes, much more consistent because everything is mathematically correct. When working the old way, when you drive the UA from a mock-up and reverse engineer it, you have much more freedom how to break it down to elements and understand their size and positioning. And mistakes, they happen all the time. In this case, they are more or less eliminated. So quite a lot of advantages for the developers. As our main job, we run a development company that builds different products for IT clients, products from different industries, different scale, small ones, big ones, and also the stage they come to us differs a lot. Some we start from scratch, some we overtake from other developers. And in the last part of the lecture, we're going to talk about how we train new teams to start SDD in projects, in different stages. Either they are new ones and old ones.
We start this from design side, so let's hope it still works. So when we start with a new project, what is important? We start communication between the design side and development side at the stage when we have only wireframes. It can be that level of very rough sketches. It can be more refined wireframes. We have to understand what are the elements, and they are visible already here. Here are some buttons, here are some icons. So we see them rather early, because we start with basics. We see them rather early because, as I have said in my previous section, the basic elements show up on every interface, or the majority of them, and they show up rather early. So we start with discussion on the basics between the front ends and the designers, and we do not touch the appearance, what we discussed, the naming conventions, the structures, the parameters, the limitations, so that when the designer goes back to the wireframes and refines and applies the visual style in whatever form we have it, and goes to more beautiful variation of these wireframes and creates this element in the library, these things, the naming conventions, the structure and everything is already defined and it's already there. So from the beginning, I'm drawing correctly. From the beginning, I'm drawing with the right elements. And for that, when starting a new project, we have to start very early, not waiting for the final design to break it already. We have to start early. So basically, that's the main, and that's the most important, probably the only rule that we have to remember about starting the new project. The rest is close to what I have described in theory. When we have a existing product, existing interface, then things become more interesting, right? We have a product itself to understand and to make sense of. We have to derive the system that is already behind the existing interface. And most probably you'll have to clarify this system, correct it, and minimize it. How we do it, I will show on a non-IT example. I have a son, and like kids of his age, he plays a lot with Lego. These are the cars that recently stood on his bedside table. By just looking at these cars, it's difficult to see what elements they're built from, how many of them there are, what is their structure, how many of them repeat themselves. And we have to derive the system from this, we have to disassemble these cars. Luckily, my kid was curious enough to count these elements, so we have disassembled them. And we left one instance of each brick or wheel or whatever on the table. And here's the result. One instance of each. 174 elements for these 4 cars. And these are only unique elements. So this gives us quite a good overview of what's happening here. We will also try to group the similar elements together. Kids was helping, so it was not complete success, but we tried. And that is what we are trying to make we have to make for the interface. And this is called interface audit. We screenshot all the views, or as many views as is humanly possible, of the interface, and we need to capture one instance of each UI element, of each element that we see here, and put them in some document, Google Doc, PowerPoint, sketch file. And this is part of a interface audit of a security app that we were building. And we have pretty good overview of what's happening in this part of the elements. And for example, we see that the buttons here, there are very many of them. Far too many. It's a very small app, very few screens. So there are far too many buttons. So what we need to do is to systemize it and to try to arrive to a smaller set. We need to see if there are 2 or several same or similar looking and behaving elements that we can merge together. So that instead of several, we have 1, if we can do without some of the variations. We did the same as Lego, and here's the result. 69 elements. Poor kid, so few bricks. No, because these are the cars that can be built from these 69 elements. From 174, he built this. From 69, he built this. this is what we are trying to achieve for the interface, to arrive to the minimum set of elements that will allow us enough flexibility in the result. So that we have the possibility to have varied views, but at the same time they're visually consistent and the base of the elements is as small as possible. So this is the goal, and to arrive from this, for this specific product, we arrive to this. And so the goal of this stage of when we are working with existing interfaces is to understand what we have and to understand what is the system we want to arrive to what is this minimum set of elements. But then it's what I want to arrive to, what us designers want to arrive to, but we have the product. How do we actually go there? How we implement this depends a lot on the implementation, and then it's Arvid's turn to tell about it.
Yes. How do we integrate gradually the style guide-driven development in an existing code base? All software that has been around for a while has legacy. Probably all know that. It has most likely been maintained by several developers, and several problems can be observed in these cases. There are different levels of hard coding. Values, colors, etc., fonts, margins are scattered around in the interface and not standardized. Of course, that leads to problems. If no reusable components are used in the previous interface, that's okay. Obviously, you have to make new stuff when you make new screens. And when the code is not made for reusability, we see that since it's copied and not reused, it's very far from don't repeat yourself. The more copies of an element, of course, the more you have to search for them and fix all places. And it's a lot of testing and a lot of feedback loops in order to fix all the problems. The original design system is either non-existing or has been applied in different versions over time. So the result might be a messy implementation of the user interface and makes it hard to do substantial changes. When can we start with style guide-driven development in an existing code base? It's never too late, so what about today? Start with making standard elements locally where you currently make changes. Try to extract the global parameters and make a library of elements of the ones that you are currently changing. Like this example, here is an actual design screen from this personal safety application. The button and the other UI elements is then made in a library. This way, the standardization of the user interface starts to evolve. And since this is a small application, we did just apply all these similar buttons all across the interface before we released it. And the first time you're implementing an element, here you have many parameters already that you can put in a global section. Primary color, typography, to name some of them. And if the designers are available, discuss with them how the design system is supposed to work. When the next part of the user interface is to be changed, we have more tools in the toolbox. And we create components of the new elements that we see on this new screen. So, starting STD with an existing project, begin to standardize parts of the user interface you currently change and iterate over this. What about the new product? So, if you receive the design from the designers, spend some time reviewing it. and discuss it with the designer, like Tatiana has mentioned here, and organize the global parameters so that you bring them to one place. Understand the elements and bundles. You go in and look at the different, more or less complex parts of the user interface and try to group them logically. And put all the elements and bundles into the library. To summarize what we have talked about, let's say if you need to go from point A to point B, you need a car. In Norway, electric cars can drive on bus and taxi lanes, so it's faster. And they can park cheaper, and the fuel cost is also much lower. And it's more sustainable model from the global perspective. Yes, you can also buy a traditional diesel or gasoline car, and it will serve the purpose. It will take you from A to B, but it does not have the advantages that I have just named. The advantages of Styleguide-Driven development are the same. It's faster, cheaper, and more sustainable. Thank you.
What mechanism did you use to move your library of styles from your library into your code?
Can you repeat the question?
Please.
What mechanism did you use to move your styles from mock-ups to the library and into the product?
Well, the mechanism we use is we try to name things the same way, and we try to organize the hierarchy and the structure the same way. In that way, it falls into place in both sides, sort of.
I meant more, do you do them manually?
Yes.
Yes, yeah.
Every style change is manually mapped through to the library and manually mapped through to the application.
Yes, we don't have direct connection as today. It might be that we do that in the future.
Okay, thank you.
Yeah.
Follow-up question to the previous one. How do you verify that the code transformation has been successful from the mock-up to the final version? So, I mean, pixel per pixel verification and so forth.
I guess we can answer
Well,
both, but pixel perfect, at least in the products that we are currently building, we don't have those harsh requirements. But if we follow the style guide, we see it's much easier to get close to pixel perfect or pixel perfect if we collaborate this way.
If we understand what properties belong to what, say, like Arvid described about the paddings of the elements, they, by just applying an element under element under element with the correct parameters, they just fall into places by themselves, because if we define these elements correctly, then this dynamic content sticks together seamlessly without verification of every pixel. That's the goal too. There was some question over there since the beginning.
Yeah, let's wait for the microphone.
Over there.
I'm just curious about the parameters you just mentioned. If you, for instance, suddenly have to support the site in Chinese and your buttons actually explode, so the whole design looks quirky.
If we need to support design in Chinese,
Do you analyze the local language you're going to support for the solution before you start, or what do you do?
well,
there?
we can also decide that we need to support something in Arabic that starts from writing from the right. In this case, we shall have to understand how there will be transformation rule. In one of the screenshots, there was transformation rule between the web and the mobile. In this case, there will be transformation rule based on the language or based on the direction of the writing. But then it will be, we understand what needs to be transformed, describe these rules, and then apply them again on both sides.
And it's since we already have a reasonable structure in the styling and the components, then it's much easier job because we know where we must apply our changes, and then we sort of know that it doesn't break all over the place. So, yeah.
But this example you were showing was using rules defined in code. Have you any experience with using the designer in the iOS, where you want to use the constraints without programming them, but still want the calculation of the forms and the views?
We building some of the products are in iOS and
but
Android.
where you still use the designer for some of the things, or
Well,
combining the
we don't
things?
make a very native something. So when we are building the product, of course, if you make a native, then there is a system already. In this case, it probably will be the part of the iOS developer work to correct this, to make this consistent with the design. So probably the designer part of the work will be smaller, but in all our products, we still have, we have a dual design for Android and iOS. In this case, we need to make a compromise between our own style, the iOS-oriented style, and the Android style. Some of the elements do differ for different platforms, but we're trying to understand where we can keep them similar. But the design in these cases, at least in our cases, it was still necessary.
But we want to use the same thinking around how we organize the parameters, and we are currently now preparing one of our apps to white labeling as a SDK. So we take all the content of the app, deliver to third party, and then they must be able to either reuse our components and apply different styling, or they can implement completely new screens by themselves. But if they are using our components, obviously they need to change a set of parameters so that the interface doesn't break when you apply new parameters there.
Thank you first for the talk. It was really very informative. Do you guys have any experience working with multiple teams who then are contributing to the same pattern library? And maybe you could speak to that as far as a lot of this is a commitment, right, to speaking the same language, using the same language. And I've experienced a lot of disruption when you have multiple teams trying to contribute to a single pattern library. And then the second question is about third-party application integration and that sort of crashing into your pattern library.
Multiple teams, when I started looking at this question, this contribution from multiple teams, at least at the time when I was researching this, was covered by other lecturers. People talk about how we do this for corporates, for big corporations. And in this particular example, we try to concentrate on doing what works needs to be done, not what the roles are that contributing to this. So the answer to your question is we have sometimes we have several designers working on or successively working on the same system. We are not running huge projects that need several design teams, but we have this sequential work from different designers when we need to shift them around. But the thing is that we train them, we train these teams ourselves, we train them thinking this way, and that helps to do this correctly for different projects. And
we have a code core that is sort of replicated across different projects, and the same core is used for Ember, Angular, so it's sort of adaptable. We are not so much we try to avoid tying it too much into one framework. So this core is used across different projects. So the main thinking behind it is the same, but the level of implementation might vary. We are not yet synchronizing all different projects into one, but I guess we are still in the phase of where we develop this core, but we will standardize it once we think that is sufficient. But that works well for us at the moment. Then it allows us to also push everything further.
Have you had any experience implementing this approach in an existing project? If so, has there been any, conflicts or problems communicating this approach to the client in sense of additional expenses, costs, and so forth?
Well, yeah, what we see on the cost side is that because we have spent 2 years now, me and Tatiana working together, and we started our work by looking at lean business development and user experience process and agile development, tie everything together. So that's how it started. And if we are using the lean approach to also applying Style Guide to existing product, we see that it's easier to make changes, and it goes faster once we have learned this. But we have spent some time understanding how we can do this smoothly. But now it gives much better result every time.
Another thing when working with clients is, as we have shown on this personal security app, we don't sell the idea, let's make a design system. Because there is a necessity to build this set of features, say onboarding. For the onboarding part, we need the buttons, we need forms, we need labels. And these are the elements we start standardization from. As Arvid has shown, this screen had inputs, buttons. We code them for this specific screen. So we're making a job for this specific screen, for this specific part of functionality, and then reusing these library elements, substituting in some other places of the interface. It can be done in one go. It can be done in many goes. But it's not effort just to establish the library. Again, we are doing it continuously. That's what simplifies selling to the business owners.
Hello, thank you for the talk. I was wondering if you could tell me, or if you can highlight some of the advantages of something like Bootstrap, something where you can agree that we want to use this style of button, for example, and then you can tell developers that, and then you can decorate your HTML with it. So that would give you. Yeah.
I can answer quickly, and then you can answer. We are not specifically targeting one specific framework, so applying these patterns can equally be done in Bootstrap. What we experience is that if we use too much of the thinking that has come from other places, we will meet boundaries. And that is the feedback from our front-end developers, that, okay, suddenly you meet a problem that is very hard to overcome because you use a framework that has its limitations. So this will work with Bootstrap. It's a good way of working. So use Bootstrap if you want. But we have organized it slightly different.
I guess you have answered.
Okay, yeah.
So it's a process of thinking about it.
Yes.
Yes. Naming, consistency, that things are equally thought about on the design side and developer side. All these things, suddenly things becomes clear. Yeah.
I guess no more questions, right? Oh, there is someone in the background. Okay.
A couple of questions. I would like to know more about the limitations that you may encounter in the system. For example, talking of reactive pages, so size of elements that may change under different conditions, or when the data may be very long, or change the shape of your element. Do you design a screen for any possible situation, or also for animations, things that may change? Do you have established some rule to do with this?
When it comes to a change of the content, I've described it when I was describing the buttons, how we measure and how we understand how this changes, what happens if the content changes. We define the rules how this element is defined based on the content. And yes, I understand that, for example, a label cannot be 10 lines long. So we establish for ourselves what is the limit, and we establish for the users, say if there is an input or some text that users can input, we count how many, what is the maximum number of symbols that can be used here in order not to break everything. Then we set this limit on the front end, and that's it. So we optimize the design. Okay, it works for this, it works for this, it works for this. Okay, then these are the rules that works for all corner cases, and it works for everything.
But yes, we have obviously a grid system, and we also have system to detect desktop and more narrow to mobile display. So yes, we take into account this, and we must be careful when we craft components that are going to adapt to different screen sizes, obviously. But we find it much easier when we are using this system anyway.
So it's to establish the rules, and if the rules work for corner cases, they work for the mainstream.
So maybe you can try applying the rules to a different screen and see if everything works. So
yes.
you and creative tools.
Yes, we do that all the time.
Yes. Thank you very much.